Good day everyone, Sir Ian here and welcome to IG Science Outlook, your quick guide for all your science tutorials. So let's get started. Today, we will be discussing about the rate of reaction. The rate of reaction is the change in concentration of the reactants or the change in concentration of the products divided by the elapsed time. Mathematically, it is given by this equation. Rate is equal to the change in concentration over the elapsed time. Consider this hypothetical equation. A plus 3B forming 2D. The reaction rate can be stated in terms of decreasing concentration of reactants or increasing concentration of the product. So the rate is equal to negative change in concentration of A over the elapsed time equal to negative 1/3 change of concentration of B over the elapsed time is equal to 1/2 change in concentration of D over the elapsed time. This means that for every 1 mole of A that disappear, that is only 1/3 of B that disappear, and only 1/2 of D that is formed. Take note that the change in concentration of reactants are decreasing and it is taken to be negative, while the change in concentration of the products are increasing and it is taken to be positive. So the rate is equal to negative change in concentration of A over the elapsed time is also equal to the negative change in concentration of B over 3 times the elapsed time, or also equal to the change in concentration of D over 2 over the elapsed time. Now the change in concentration of A is equal to final concentration of A less that of initial concentration of A. Take note that the change in concentration of A will give us a value that is negative simply because final concentration will be much smaller compared to the initial concentration. Now this graph will help you figure out why a change in concentration of A will be negative. Now see for example your initial concentration is 0.2. Some point in time, say for example somewhere here, your final concentration will be much smaller to the initial concentration, giving you a value of the change in concentration of A that is negative. So the rate is equal to negative concentration of A over the elapsed time will give us a value that is positive. It's like an object moving in the xy coordinate system on the negative x direction where it is taken to be negative, but the distance covered is positive. Similarly, the change in concentration of D is equal to the final concentration of D less that initial concentration of D. And your change in concentration of D will give us a value that is positive, simply because concentration of D final will be much bigger compared to concentration of D initial as time progresses. A graph will help you figure out why concentration of D will be positive. Initially, the concentration of the product is 0, and as the time progresses, the concentration, say for example, somewhere here, it will be higher than the initial concentration. Okay, let's take a look at this sample problem. Hydrogen gas has a non-polluting combustion product, water vapor. It is used as fuel aboard the space shuttle and in earthbound cars with new type of engines. The reaction is given below. 2 moles of hydrogen gas reacting with 1 mole of oxygen gas to form 2 moles of water. Now we are tasked to determine the rate in terms of changes in concentration of H2, concentration of O2, and concentration of water with time. In letter B, we are tasked to determine the rate at which water is increasing while the O2 concentration is decreasing at 0.23 mole per liter per second. Okay, now for our solution for letter A, express the rate in terms of changes in H2, O2, and water concentration with time. We would expect that the H2 and O2 concentration are negative because they are reactants, while that of water is positive because it is a product. Now for letter B, we are tasked to determine the rate at which water concentration is increasing. So from our answer in letter A, in which the negative change in concentration of O2 over the elapsed time is equal to 1/2 the change in water concentration over the elapsed time, and since we are only after in the change in concentration of water over the elapsed time, we write it on the left side equal to that of the negative change in concentration of O2 over the elapsed time. We can then substitute the values for the change in concentration of O2 per unit time, and that is negative 0.23, and that is because it is decreasing. So working out mathematically, we can have a final answer that is equal to 0.46 molar per second. Thank you for watching. Don't forget to like and subscribe for more science tutorials. See you next time.